All right, so today's lesson is on the triangle proportionality theorem. Don't forget your date. You don't want to lose points. Today is the 13th. And again, this is going to be similar to what we have been doing. So we're going to set up proportions, cross multiply, and solve. Okay? But let's start with our definition of what the triangle proportionality theorem says. So it says, if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. In the last module, I tried to have you guys compare the small triangle to the large triangle. And we needed that for when we were proving the triangles were similar. In this case, we can still do that, but we can also compare the pieces, which some of you did in the last unit, and it worked when we were just solving problems. But remember I said there are like a million ways we can set it up as long as you're comparing the same pieces. That's what we're doing here, okay? So let's look at a triangle. This is part of our definition still. Which two sides would be parallel? EF and BC. How do you know they're parallel? Those arrows, right? Those arrows tell us it's parallel. So the triangle proportionality theorem says, if there is a segment that is parallel to the other side and intersects the two sides of the triangle, then the pieces are proportional. So AE and EB would be the same as AF over FC. So this piece to this piece to this piece. You have to compare the same pieces. Okay, that is the biggest thing here. You have to use the same pieces. Are we okay with that? You understand what I mean when I say you have to use the same pieces? Yeah? Okay. And let's solve some problems. Okay, you're comparing the same pieces. Anyone have a guess at what our proportion might look like if we're comparing pieces? Well, I heard 1 plus 4x over 5 equals 20 over 4. Perfect. Okay, so this piece to this piece, and then it's the same pieces on the other side. You just have to compare the same things. And now it is literally exactly like what we've been doing. So I can simplify just to make my life a little easier. That becomes 5 over 1. And now I'm going to cross multiply. So 1 plus 4x equals 25. I would subtract 1 from both sides, so 4x equals 24. X equals 6. Are we okay with that? Yeah? Okay. Let's try another one. We're going to do this one together also, and then I'm going to give you a couple to do with your group. So again, you're comparing the same pieces. Can someone help us set it up? Kendall?
4x minus 3 over 18, and then 4 over...
That's an 8.
Okay,
Yeah.
8.
4 over 8. Perfect. So again, 4x minus 3 over 18, and then 4 over 8. I'm going to simplify again just because it makes my life a little easier. When I cross multiply, I get 8x minus 6 equals 18. If I add 6 to both sides, 8x equals 24. Whoops, that is not right. How about 3? X equals 3. Not too bad? Okay, I'm going to give you 3 problems. You can work by yourself, you can work with your group, but I do want you to check in with your group to see if they have the same answers you do. I'm going to flip the page so I can have more room. Everyone have this down? Okay. So here are the 3 problems you're going to do. You don't have to flip your page. I'm just doing because I wanted to have it all on one page for you to see. So squeeze it in where you have it. So here are your 3 problems. Again, compare the pieces. You can work with your group. You cannot work with your group, but I do want you to check your answers. They should all be whole numbers. There shouldn't be any decimals for these problems. Okay? Someone from group F, help me set up my proportion for number 3. Anyone from group F? What do you have? Okay.
I'm going to say 6 over x plus 5
Okay.
equals 4 over 6.
Perfect. 6 over x plus 5 equals 4 over 6 is perfect. So they took this little piece here and compared it to the whole thing. So I need the same little piece on the other side and then the whole thing, which is 6. Did anyone use a different proportion that they want to check to see if it's correct, maybe? Nathan?
I got x plus 5 over 6 equal to 2 over 6.
Okay, so that one's not going to work because you use the whole piece for this x plus 5, so you need 6 for the other side. Okay, so let's cross multiply and see what happens. I'm going to reduce first, so that's 2 over 3. Giving me 2x plus 10 equals 18. If I subtract 10 from both sides, I get 2x equals 8, which means x equals 4. Okay, you have to compare the same pieces. All right, how about someone from group I? Can you help me set up number 4? Okay. So 21 is the whole thing. So what's the whole thing here? 14. So 21 over x equals 14 over 6. because it's this small piece in the whole thing, so you need this small piece in the whole thing. They have to be the exact same pieces. Did anyone get a different setup? No? Okay, so let's simplify that one. 7 and 3. So what's that? 63 equals 7x, divide by 7, x equals 9. So if you have a different proportion and you got x equals 9, then your proportion is just fine. If you have a different proportion and you did not get x equals 9, then you need to fix it. You are not comparing the same pieces. How about someone from group D for number 5? What do you have?
14 over x equals 7 over 3.
Perfect. 14 over x equals 7 over 3. Okay, so they took the whole thing over this little piece here. So I need the whole thing, which is 7, over that little piece there. You see what we're doing? Okay. Here I'm going to cross multiply. So what is that? 42 equals 7x. X equals 6. You could have also found these little pieces, right? And then you could have just done the 2 pieces like we did in the first couple of problems. So for instance, if I come back up to number 4, can someone tell me what this piece here is going to be? Anyone know? Huh? So if the whole thing is 21 and this piece is x, how do I find this piece? You do 21 minus x. Right? If this whole piece was 10 and this little piece was 3, how would I find this piece? 10 minus 3 would be 7. Okay, it works the same way. The whole thing, if we subtract the little piece out, so the whole thing minus the little piece is going to give me the other little piece. You learned that in IM1. Are we okay with pieces and we know what we're supposed to compare? Yeah? Are we sure? Yeah. Okay. Last problem. No? We need to determine whether the given segments are parallel. Determine whether the given segments are parallel. So we're doing the converse or the opposite of the triangle proportionality theorem. So the triangle proportionality theorem said if those 2 side lengths are parallel and this middle side intersects the other 2 sides of the triangle, then the pieces are proportional. Here, we're going to assume the pieces are proportional right now, or we're going to check to see if they are. And if they are, we can show those 2 sides are parallel. What 2 sides are we going to show are parallel, potentially? Kendall?
75 over 9 and then 100 over 12.
So you're setting up your proportion. 1 second. What 2 sides are we going to show are parallel? PQ and NM. We want to show those 2 sides are parallel. So Kendall said 75 over 9 and 100 over 12. It's the same pieces on each side, right? What you're doing is you're finding scale factor. You're seeing if those 2 ratios are the same. Can I reduce 75 and 9 by something?
Yes.
What? 3. 3 goes into 75. 25 times. 3 goes into 9. 3 times. Can I reduce 112? Yeah? By what? 4. 4 goes into 100. 25 times. 4 goes into 12. 3 times. Do they have the same ratio? They do, which means PQ is parallel to NM. If they didn't have the same ratio, then those two lines are not parallel. Questions, comments, concerns?